Several years ago, an engineer at Adobe built a system called SpotStack. It was a custom infrastructure layer designed to hunt down and provision the absolute cheapest cloud compute resources available on AWS. But competing against a cloud provider is a losing game. They possess nearly unlimited development power and total visibility into how customers save. AWS eventually released a native feature called Mixed Instance Groups. This allowed users to request multiple instance types at once, performing the same multi-instance scaling tasks as SpotStack, only faster and more efficiently. The release of Mixed Instance Groups made the custom system pointless. SpotStack was retired because AWS built a version that was simply better. It highlights a basic reality of cloud scale. If you build a custom tool to optimize their platform, the provider will eventually build a native version that renders yours obsolete. However, one anonymous engineering team managed to break that cycle. They successfully outbuilt the native AWS tools. They achieved this by taking 4 distinct cloud optimization concepts and integrating them into a single, unified architecture. How did a single team create an autonomous system that outperforms the very giant that owns the platform? The foundation of their success wasn't a better script, but a shift in metrics. They stopped looking at server costs as a finance report and started treating them as a primary engineering signal. Traditional cloud provisioning assumes that moving to a smaller instance or a newer hardware generation automatically results in better efficiency. They benchmarked every server under actual load. On the left, the sticker price, cost per hour. On the right, their dynamic metric, cost per transaction. Output across architectures like Intel, AMD, and ARM proved wildly unpredictable, even with identical hourly rates. Focusing on hourly rates is a blind spot. Tracking the actual cost per transaction is the only way to reveal the true value of infrastructure. To make this data actionable, the team used a specialized mechanism, auto-scaling group instance weights. Many architects treat weights like a simple ranking of their favorite servers. In reality, weights allow you to define capacity in your own custom units. The auto-scaling group ignores hardware size, focusing purely on transactions per second. Machine A costs $1 for 10 transactions. Machine B costs $1.50 for 20. Despite a higher sticker price, Machine B wins, costing 25% less per transaction. By feeding these ranked value scores directly into the ASG weights, the team created an infrastructure that acts as an autonomous value hunting engine. This logic resulted in a 3-tiered auto-scaling group system where every layer has a specific job. The first tier is the baseline, a static footprint using compute savings plans for minimum capacity. The second spot-only hunter tier uses weighted throughput data to dynamically hunt for cheap transactions. A strict max price cap, calculated for benchmarks, matches their on-demand baseline. This cap is the key. It defines the exact moment spot instances stop saving money and start becoming more expensive than standard rates. Because the system is built on earned data, it can autonomously refuse bad deals, even if spot capacity is technically available. The final layer is called the failsafe. This is an on-demand tier, triggered by the same metrics as the spot layer, but set to a slightly higher threshold. This failover operates with a fluid motion. It steps in seamlessly when spot capacity thins out and retreats the moment the primary system recovers. As we see here, if the spot pools become too expensive or unavailable, the on-demand tier expands to fill the gap. When spot recovers, it steps back down. This interplay creates a loop of absolute stability, while maintaining the lowest possible cost per transaction. While this architecture is highly efficient, it requires a very specific environment to work. It must be entirely stateless, must be horizontally scalable, and have crystal clear throughput metrics. Without a rigorous benchmarking foundation, this 3-tiered pattern will fail in production. If the data used for weights is inaccurate, the entire system is just noise. Efficiency on this level isn't something you can simply buy. Using spot instances effectively is a reward that a team earns through the discipline of their architectural design.